play with hash extension. So here I've got a website. You can log in. So if I go to this website, you can log in with the username Joe and a password Joe. And when you log in, you'll get in, and it's going to show you what happened. It's had an authorization cookie, which is an MD5 hash, then a pipe symbol, then username equals Joe. And what's going on is this is claims to be Joe, and this is the signature, which proves that you really are Joe. All right, and so that's received the cookie with hash. The hash was this, and the data was that. The server authenticates to make sure that this signature matches that claim and only lets you in if they match. So I logged in successfully as Joe. All right, now what we want to do is, that explains how it works. So now we're going to use burp. See if I still have burp running. I don't, I'll launch it. Burp, you just install it on your host operating system. You could use it in a virtual machine, but there's no need to. It's not malware. Free, get the community edition. That's what I recommend. You can get the professional edition, but it'll only give you like a 90-day trial or something. The community edition's fine. Doesn't matter. Either one's fine. So you start it. And by the way, it has a native version for Apple Silicon now, which is nice. All right. So when you get it going, you go to the proxy tab, make sure intercept is off. I've also noticed the latest versions of burp finally have intercept off by default, which is great. It used to be on by default, which frustrated new users. So now you can open a browser. There's an open browser button. This is the fun way to use burp. Click open browser, and it will open a browser that's automatically connected to burp. There used to be a sort of confusing step where you had to connect your browser through the burp proxy, but that has been removed now. We can just use the built-in browser. If it'll open, I think it'll open. I think it's just slow. There we go. Just have to be a little patient. So this browser goes through burp. So let me go back to my instructions for the project. All right. So go to this website. I'll copy this link address and go into the burp browser and put that in. All right, and then enter. Okay, so it loads that page, and I can make it bigger in there. All right, so now if I go to burp, which is back here, all right, I can go to proxy, and I can go to HTTP history, and I can see there's been a get to load that page and a get to load the little icon up in the URL bar. So that's just loaded the page. But I want to get a login. So I'm going to log in as Joe and Joe, log in. And now you see a post request. And the post request is typically what logins do. And so if you look down here, you see user U is P and U is Joe and P is Joe. This is play post request send data. So this is the request that sent my username and password to the server. And this is the reply that said I was accepted. So let me go to look at my instructions again. Find the get request that loaded the welcome page. Right, after it accepts you, it then sends you a welcome message, which is here. And I'm going to send that to the repeater. The repeater lets you modify and resend that. I don't need this. So here's the raw request. And see here, I've logged in. In response to the post, the server sent me my hash to authenticate myself, which was constructed of a secret on the server. So the way this works is, it takes this phrase, username equals Joe, it adds a secret to it, which I don't know, and it hashes that with MD5. That's how it makes these signatures. And the question is, can I log in as administrator without knowing the secret? And the answer is you can, because of MD5 linked extension attacks. You can take an MD5 of something and you can construct the correct MD5 of something that's longer by adding more data to the end without knowing how to recreate the first part. And since the secret comes before the data, this will work. That's what's going on. So that's if I send this request right now, then the response will tell me you're accepted as Joe. Welcome, Joe. But if I change anything here, like if I try to change this to administrator, and send that, then the response is going to say cookie invalid. You can't get in. You said administrator, but that is not the right signature for administrator. And I don't know how to create the right signature. So to do that, I just need to perform a linked extension attack, and there is some software that does that. This thing called hash extender. By the way, it was broken when I tried to use it a few hours ago, but I found the flaw and fixed it. That's why we're using my fork. So we needed just a little bit of change to make it work in the modern versions of Linux. So you git clone this thing, you make it, and then you'll have this hash extender program. So let me just do that here. If I git clone from my repository to get the repaired version of this thing, let me make a directory demo and go in there. All right, now I got nothing in here. I can clone this thing. All right, and now if I do ls-l, I have a directory called hash extender, so I go in there. And if I do ls-l, it's got a make file and all the files needed here, so you can just run make, and that will build it. And it's a pretty small, simple program, so it doesn't take any time to build. And now you can run it. And so you run it without any parameters, and it will show you what the parameters are. And here's what we have to do in this case. We know already, in this case, when you log in, we know what we're going to see. We're going to see this hash starting with 7C, and the data is username equals Joe. So this is the way you use hash extender. The data is username equals Joe. That's signed. Here's the valid signature for that data, starting with 7C. Then I want to add to the end and username equals administrator. I want to make an MD5 hash. The secret that I don't know has a length of 12. You need to know the length of it. And then it will create a new signature for that. And the reason this works, by the way, there's two flaws. The first one is the secret comes before the data, so you can add more data at the end. And MD5 has this flaw that you can add an extra block of data at the end of the first block without, and predict the MD5 of that longer string. The other flaw is if I send this web server username equals Joe, and then later on in the request, username equals administrator, this is called parameter pollution. I've defined a parameter twice, and this web server will fall for that. It will just accept the second name. It won't give you an error message or just take the first name or anything, which some of them might do. So those are the flaws that we're exploiting here. So if you run this thing, there you go. So what it does, it now creates a new string, which is username equals Joe. Then it adds a bunch of nulls here to pad it out. Then it adds username equals administrator out here far enough that it's going to be outside the first block of data, and adding a new block of data at the end. And since it knows the signature of the first block, it can add the second block, and it can predict the signature for this. So now I can log in as administrator. I need to just carefully paste these things in. I need to put this in as the signature. Now the way this works, the signature goes up to that %7C. %7C is the pipe. So you have to be careful. Delete the data up to %7C and replace it with the correct auth. And then the second part is ampersand username equals administrator, which looks like this. After the 7C, %26 is ampersand. So if I did that right without screwing up, I will now accept me as administrator. And it did. Nope, cookie invalid. So I failed. Wonder what I did wrong. Let me go back and see. My new signature should have started with 17, and it did. Okay, and this should have been %26 username. Okay, looks like it should have worked. Let me see if I can debug my attack here. Let's go back and get the original thing again. If I go back to the proxy and send this to repeater again to get a clean, fresh one, okay. Let's make sure this one works. I send it, and response says, welcome, Joe. Okay, so this one is good. So now I want to put in, I just have to make sure and copy and paste correctly. That's all it takes. I want to take the MD5 hash, which is there, and replace it. And after the %7C is where I put this mess, which is, let me make my window a little smaller here. Oh, and make sure it's all on the screen. Okay. There. %26. Oh no, that's right. I have to put all this stuff in here. That's right. That's the string. That's what I did wrong. You have to take all of that stuff and put it in here to match that hash. So the request gets really long. And now it's going to have username equals Joe, a bunch of junk, and username equals administrator, and that's going to be the correct signature for that. That should work. All right. Yep, now, welcome administrator. So I got in. All right, that's what I wanted to show you. And now, so the first flag is easy to find by just obeying the steps here. And there's another one you can try later where you're going to have to vary the length of the secret. You don't know the length of the secret. You'll have to try different ones until you figure it out. So that's the length extension attack, which we talked about in theory, but this is where you get to play with it hands-on. So that's it for that one.